We welcome Dr. Balaji Rao sir and all our viewers for today's session. As this session is for grade 10 chemistry, acid, bases and salt part 3. Please type the queries on the YouTube channel. We will be taking up the queries before the session ends. We welcome you sir. Please continue.
Thank you very much. Very good afternoon to all of you. We will be continuing from where we had left the last class. That was just one step backward. We talked about dilution, and from there we went on to talk about the concept of pH and a little more than that. Now, what is dilution? If you remember, I said when a liquid or a solution is treated with more solvent, then we say that it has become diluted. I gave you the commonplace example of milk being diluted with water. Or in fact, it may so happen that you might have some decoction prepared at home for preparing coffee. And maybe that decoction is enough for about 4 people. And you're about to prepare 4 cups of coffee and you suddenly find that 2 more people have joined your group. Now you don't have time to, and they're in a hurry to leave. And again, it doesn't look nice if you start heating water and then preparing a decoction. So what do? To those, that much of decoction, what you have already with you, add a little more hot water and then make it up and then give coffee to everyone. In the process, what have you done? You have diluted that decoction. So dilution is a process in which we add excess of a solvent to an already existing solution. So from this, we have come to a question: how strong are acids or bases? How do we know that? How do we say that a certain acid is a strong acid or a weak acid, or a substance is an acid or a base, or it is neutral? To know that whether a solution is an acid or a base, or is acidic or basic or neutral, what we do is we look at its pH. I remember I have mentioned a name to you, Sorensen. He was a French chemist. He called this as puissance de hydrogen, which meant power of hydrogen ion concentration of a solution. All this briefing we had already finished. Now we go a little further. Again, we are going on a retro, mode. That is, we are going back a little and then coming forward as usual. And there I had left a small graph-like thing on the board for you. I had put a pH scale there between 0 to 7 to 14, where I said 7 is neutral pH. This neutral pH is pH of pure water. If you look at it, pure water. I'm stressing on this word, pure water. I'll tell that to you in a couple of minutes. Then I said going from 7 back towards 0, the solution becomes more and more and more and more acidic. And from 7 upward till 14, the solution becomes more and more and more basic. You would have noticed that from the previous graph to today's graph, one small correction has been incorporated. I have written molarities of the 2 solutions. I have written 1 molar NaOH and 1 molar HCl respectively. Now, we will keep that aside. I use the word pure water. What do we mean by pure water? Now, if you look at the tap water that you get every day from any domestic tap, do you think that that water is having a pH of 7? No. The water that we get from the tap is slightly acidic. Why? Because during the water treatment, the water collected in the reservoir for the township or for the city, wherever it is, before it is pumped to your homes, is treated with some amount of sodium hypochlorite solution, or in some cases they use bleaching powder, or in some cases they directly chlorinate it. So in the chlorinate water, what happens? Try to write this equation mentally. I'm writing this equation mentally. H2O plus Cl2. What can it give me? HCl, of course. HOCl. What is this new compound? HOCl. I'll have to get up sometime today. Let me write this. HOCl is called hypochlorous acid. This hypochlorous acid is an unstable compound. Therefore, it breaks down into the oxygen inside the bracket indicates that it is in the nascent state. That means it is highly reactive. And this will oxidize impurities that are present in water, including those small microbial species that are existing in water. So now look at it. I have treated water with chlorine. The resultant solution contains a certain amount of HCl. Therefore, the water that you get from the tap is not having a pH of 7. It has a pH less than 7. It is slightly acidic. Then what is pure water? If you triply distill water, we use a concept here called triple distillation. Just this is a reference for you. I want you to go into a little more of this. Of course, today you have the facilities like Googling out the information. You can Google out and find out what is triple distilled water. We see that all the impurities in water are oxidized off, and what we finally distill over a quartz, in a quartz apparatus, is what we call as triple distilled water, and that has a pH of 7. So pH of 7 is for pure water or any neutral solution like a sodium chloride solution, sodium sulfate solution, potassium chloride solution. There is a meaning behind every of these compounds that I mentioned. So if you look at it, sodium chloride solution is a solution of NaCl produced from HCl and NaOH, both of which are equally strong. That means both of which give rise to equal number of H plus and OH minus ions. Therefore, the solution will have equal number of H plus and OH minus ions, and therefore it will be neutral. Same case with sodium sulfate. Same case with potassium chloride. Same case with potassium nitrate. The salt of any strong acid by a strong base. We will be a little ahead. We'll be looking at this once more. So the solution of any salt of a strong acid by a strong base will continue to have a pH of 7. So anything beyond 7, I said, is basic alkaline, and anything below 7 is acidic, increasing acidic nature from 7 towards 0. Now let me see some biological fluids. How far does sorry, how far does this pH affect our human system? Are we dependent on pH at all? Yes. Our body has, generally speaking, our body runs between a pH of 7.0 to 7.8. That is from neutral to slightly basic. This is the small narrow window of pH that in which the human body works properly, underline properly. Let me see some of the important fluids that we have seen, or we see, or we experience. We start with saliva, the first entry point. You must have, this is a new concept, a new advertisement that you're getting to see on the television. Entry point, a small child bringing in a funnel and then saying that whatever you eat, the entry point to your stomach is your mouth. So the mouth, saliva is It has a pH of about 5.5 or around that, 5.6, 5.5, 5.7. Go into the stomach, go down deeper. When you enter the stomach, you get hydrochloric acid. You'll be surprised. The pH of the gastric juice that is inside your stomach is 1.2. That means we have an extremely acidic atmosphere inside our stomach. We will see what happens if it goes below that or goes above that, we will see. Then we'll take some biological fluids like I said, lemon juice. Lemon juice is a commonly used substance. It is supposed to have a pH of about 2, whereas milk of magnesia, that is magnesium hydroxide, which has a pH of 10, and I have mentioned sodium hydroxide, which has a pH of 14 when it is 1 molar in concentration. So the strength of an acid or a base depends on the number of hydrogen and hydroxyl ions that are produced from these solutions. Now, I used this word a few moments ago. We will come back. I believe in this going back and forth policy because it makes the concept a little more concrete. An acid that produces more number of H plus ions per liter is called a strong acid. And a base that produces more number of hydroxyl ions per liter of the solution is called a strong base. What do we mean by this? Not convincing. Definitely not convincing. If I were to take, say, hydrochloric acid, I just leave it that. I'll come back to this. If I take hydrochloric acid, if I take, let us say, for a calculation, for the just sake of calculation, if I take 10 to the power of 1, 2, 3, 4, 5. If I take 10 to the power of 5 molecules of hydrochloric acid, concentrated hydrochloric acid, and dissolve it in, let us say, 1 liter of water, I find that I will be getting 10 to the power of 5 molecules of hydrogen ions or H plus ions and 10 to the power of 5 Cl minus ions. So I say that hydrochloric acid is a strong acid because whatever I have taken, whatever I have dissolved has completely ionized. Still not convincing. I'll take one more example. Let me take another compound. Now I have taken another compound, ethanoic acid or acetic acid. It is also called vinegar. A 5% solution of acetic acid or 10% solution of acetic acid is called vinegar. We know vinegar is used as a souring agent. Now let me see how it ionizes. If I take, say, 10 to the power of 5 molecules of acetic acid, I find only two molecules will ionize into acetate ion and hydrogen ion. That means the remaining 99,998 molecules remain undissociated. Therefore, acetic acid is called a weak acid. Get the difference? See, if I take 1 lakh molecules of HCl, dissolve it in 1 liter of water, 1 liter of water, I get 1 lakh hydrogen ions. And of course, chloride minus ions is not important for me because of pH, I need only H plus ions. Whereas if I take 1 lakh molecules of acetic acid, I get only 2 molecules to ionize into 2 hydrogen ions and 2 acetate ions. The rest of them remain undissociated. Therefore, acetic acid ionizes partially in solution. Hydrochloric acid ionizes completely in solution. Therefore, hydrochloric acid is a strong acid. Acetic acid is a weak acid. So a weak acid ionizes partially, strong acid ionizes completely. Similarly, a weak base ionizes partially. For example, I could take the example of NH4OH, ammonium hydroxide. This will give me ammonium ions and hydroxyl ions. Again, the number of hydroxyl ions produced by ammonium hydroxide is not complete. That is why I have written two half equations, two half arrows. If you look at it, in the case of HCl, I wrote one complete arrow, only one directional arrow. Here I am writing two half arrows, which means that this will not undergo complete dissociation or ionization. Such molecules are called weak acids or weak bases. Now, coming to other examples of strong acids, I said sulfuric acid is there, nitric acid is there, of course, hydrochloric acid. These are the commonly, we come across these as common strong acids. Weak acids, organic acids like acetic acid, formic acid, benzoic acid, any of these. And if you look at strong bases, sodium hydroxide, potassium hydroxide, and if you look at weak bases, ammonium hydroxide and amines, all the amines that are there, you will learn more about amines as you go to higher classes. But this is only an information that I have given to you right now. Now, you might ask me the question, do we have any weak or strong salts? No. All salts undergo complete ionization. Please remember this. All salts will undergo complete ionization, irrespective of whether they're from a strong acid and a weak base, or a weak acid and a strong base, or a weak acid by a weak base. Any combination you look at it, all salts are strong, completely ionizing. They completely ionize in solution. Now, what is the importance of pH in our daily life, in our daily activity? How does pH affect the body? The human body, I mentioned to you some time back, it works in a pH range of between 7 to 7.8. And now this is the season when it is raining cats and dogs. In Bangalore, we are flooded. If you are sitting in Bangalore, you would have experienced it. We are having incessant rain for the past few days, and many areas are being inundated. A lot of waterlogging has happened. A number of vehicles have been damaged. A number of houses have been damaged, and a lot of confusion is prevailing. All right. Now, the rainwater, it is said that the first few drops of rainwater are supposed to be very pure. There's some statement I have read somewhere. The first few drops of water, rainwater, are supposed to be very pure. And in fact, rainwater is one of the purest forms of water. But in today's scenario, what is happening, because of extreme urbanization, extreme industrialization, we are spewing out large volumes of acidic gases into the atmosphere. We are letting out a lot of nitrogen oxides, huge volumes of carbon dioxide, large quantities of sulfur dioxide. So all these get settled in the upper atmosphere. And when it rains, they also come down with the rain in the form of their dissolved forms. That means they come out in the form of their acids, the respective acids. Now, if the rainwater is somewhere the pH of the rainwater is slightly less than 5.6, then we call this as acid rain. This is a question that could be potentially asked. What is acid rain? When the pH of rainwater is less than 5.6, that rain is supposed to be called acid rain. Acid rain affects people and the land, of course, and of course the vegetation, irrespective of who it is, what it is. In case you get affected by acid rain, it might leave some skin rashes, disorders. And if it falls on the ground, it makes the soil acidic. It may not help the cultivation of crops for a long time. So pH of rainwater is one of the factors that determines the overall air quality that you have around us. Then, when this rainwater, if it, let us say it enters, we cannot stop it, let us say now, it has already fallen, it has entered the rivers, and the rivers also become slightly acidic. The water in the rivers also becomes slightly acidic, and in such acidic atmosphere or environment, you find that the marine or the aquatic life, the fish and whatever lives in water, they are also affected. We do come across sometimes newspaper articles or even television, but they do show this, that in a certain lake, a number of dead fish all of a sudden showed up. That is because of lack of oxygen and acidic environment in the water. All right. Now, here's a small activity that I think you can try out yourself. You can collect soil from different places around you, wherever you are, and try to check the pH of these soils. It's very easy. Just put that into a test tube, put water, take a pH paper and dip it into that, take it out and compare it with a strip of standard strip that is given to you. You will find what is the pH of the soil that you have taken. And you can plant different types of seeds or plants into these different types of soils that you have collected, and see how which kind of a soil is more beneficial for a given plant growth. This is only an activity. This you can try out when you have, of course, you have a lot of leisure now. Anytime that you're free, you can do it out. Then of course, you can do one more thing. In case you have somebody else coming from your relatives from different places, ask them to collect their soil or whatever the soil they get around them, and try to make a comparison of that soil with the soil that is available with you around your house, and see which plant grows better in which soil. And that also will tell you what is the pH that is required for a certain kind of a plant growth. Right. Now, pH of our digestive system. We started with the mouth, we went into the saliva, we can have entered the stomach. As I said, we have in our stomach hydrochloric acid. Long ago, I had come across an article. I don't know how authentic was the article, but there was a photograph printed, so I assume that to be authentic, where it appeared that somebody was shot in the stomach, a person was shot in the stomach during a war, and they couldn't virtually close this hole. There was something wrong, and the whole thing had healed up, but you could still have a peep into the stomach. That is what the article is. This is an article which I read probably some 30-40 years ago. I don't remember where I read it, and I don't vouch for the veracity of the statement as well. But anyway, there one of the doctors had removed hydrochloric acid from the stomach. That was what the article read. That hydrochloric acid was able to dissolve a shaving blade. So that was what the article claimed. This long ago. So I don't really vouch for the statement, but I remember to have read this. Anyway, besides that, the stomach does produce hydrochloric acid concentrated, and we have a healthy 1.2 pH inside our stomach. What happens when we start eating, when we start chewing food? The food begins to undergo digestion in the mouth in the form of, with the help of an enzyme called salivary amylase. It's called talin, Ptyalin, talin. This talin helps the food to be broken down partially. That enters the stomach. When it enters the stomach in the presence of hydrochloric acid, the carbohydrate that we have consumed, that is rice, wheat, whatever, is oops. What
Dear viewers, kindly hold down. There is some technical issue. So, sir will be joining us within a second or within a couple of minutes.
Welcome back, sir.
Yeah, thank you.
Please
I'm
continue.
sorry, my friends, there was a small glitch.
No worries, sir. Please continue.
Yeah, I'm sorry, there was a small glitch. This is sometimes the technology works in a very strange way. All of a sudden, my battery was showing very low, and I don't know what happened to it. So I had to log out and log in again. This is the bane of the technology. Sometimes it works the other way around for you. All right, leave it.
No worries, sir. But it is connecting experts like you to thousands of viewers. So a
I
little
know,
bit
but
glitch
then.
is okay.
Thank you, G.
Thank you, sir.
All right. So I hope I'm audible now.
Yes, sir. Very much.
Okay, thank you. I'm visible too.
Very, very much, sir.
Wonderful, wonderful. That's great. That's really great. So, friends, coming back to where we had broken off, I said that we have hydrochloric acid in the stomach, which helps in breaking down the carbohydrate further into glucose, and the glucose is absorbed in the bloodstream. It is supplied to the whole body, and then it is used for physical activity. And okay, what if you eat more than what is required for the body? If you eat more rice, what happens? The excess glucose is stored in your muscles in the form of glycogen, that is a reserve fuel for you. Even if you fast for a day or two, you will not have any problem because your body already has enough amount of stored glycogen. So this is one aspect of the glucose being absorbed in the body. All right. Now, okay, this is a season when people tend to these 15 days now, beginning from just about a few days up to probably the 17th, is a time when a number of Hindus, we follow a particular tradition where we offer our obeisances to our elders. And during that period, in their name, we eat more. Hmm? So when we eat more, what happens? The digestion, the body is not used to taking so much of food all of a sudden, so it results in an indigestion, during which to digest the food excessive acid is liberated in the stomach, and this causes what we call as hyperacidity. All of us have at some point experienced hyperacidity, that is acid reflux. You get that acid coming up your throat, up your mm, esophagus, and you get that burning sensation and all this stuff that goes with it. So during this time, people advise you to take some milk of magnesia or one of those antacid tablets. So next comes a question. Again, I'll take you to one more advertisement. This advertisement shows a young girl walking on a pavement, and much above her, a boy walking on a terrace with an umbrella in hand. Now he's trying to protect the damsel from being sunburnt, obviously. So at the end of the whole story, they say that you should eat some chocolate. And the story talks about eating chocolates. Basically, that's that. But then instead of saying eat chocolates, they're trying to glorify this by means of a very nice looking girl and an extremely handsome looking boy, etc., etc. Now, what happens if you eat more chocolates? If you eat more chocolates, and of course, eating more sweets or even more of carbohydrates for that matter, if you do not get rid of that, if you do not brush it up properly, there is a chance that the acids produced during the fermentation of this in the mouth will lower the pH of the mouth saliva, and that will attack the dentin or even the calcium phosphate that is present in the teeth and cause dental caries. So dental caries is caused, that is the teeth becoming brittle and full of holes, etc., etc. It is caused by this kind of bacterial attack on the teeth when the pH in the mouth becomes less than, say, 5.5, 5 point, so around that. Now, obviously, the antidote to this also is again an advertisement. People are using some very stupid concepts like somebody on a train journey, suddenly somebody wants to eat something, his wife is against it, and you find that all of a sudden a lady jumps in and asks whether they have a salt in their toothpaste. All ridiculous statements they make. Anyway, so toothpastes or even brushing your teeth regularly will prevent this dental caries so that the mouth is not affected. Then we have animals and of course insects and even plants. They have this self defense mechanisms. I don't know if you have been ever stung by a bee, an ordinary innocuous bee. If it stings you, it causes an irritation. And of course, the same thing on a magnified scale is in the case of scorpion, and much, much, much more magnified in the case of snakes, etc., etc. Now, what happens when a bee stings you? Why do you get that irritation? You feel like scratching. That is because that sting contains a small quantity of an acid called formic acid. In fact, formic acid, the name itself is very interesting. I'll write the name. I love doing such things, crazy things like this. It is nowadays called methanoic acid. It is HCOOH. This comes from two words. Formicus acidus. Formic acid today nowadays, according to IUPAC, we are supposed to call it as methanoic acid. Its formula is HCOOH. And it is derived its name from Formicus acidus. So Formicus meaning a red ant. So when a red ant bites you, do ants bite? I don't know. Maybe something. Okay, that when it bites you, so to say, you get that irritation because it wants to see that that area gets a little more blood circulation. It is said that these bees, when they sting, they release a small amount of formic acid. Along with that, a small amount of their venom, small bit of poison. Bee poison is not dangerous unless it is a swarm. So when it happens, when you itch, when you scratch, what happens? You find that area blood circulation becomes more, and the toxin can travel rest of the body, etc., etc. So that is just a pointer that I wanted to make. But these bees or ants, etc., they have this acid being released as a self defense mechanism. They see that they are protecting themselves against other species. So are these nettles. Nettles, again, these are plants which have a small, needle-like things around them. You can always Google a nettle. And they also have a small quantity of this formic acid, and this protects the plant from being attacked by other things. All right, now what happens? Okay, there is an ant bite, there is a small bee sting. What do I do? All you do is remember this. Whenever you have such a small emergency, try and locate the nearest place where you get baking soda. Baking soda, sodium bicarbonate. Just make a paste of that in water and apply over the wound, and immediately the acid gets neutralized. So you will not have any more itching or rashes kind of a feeling. Fine. Now we come to a little more about salts. Now we have families of salts, as we call them, families. Let us see some families. All salts coming from hydrochloric acid are called chlorides. You can list a few of them. You can think of ammonium chloride, sodium chloride, potassium chloride, barium chloride, any chloride, manganese chloride, cobalt chloride, nickel chloride. All these are called chloride family of salts. Similarly, you have sodium sulfate, potassium bisulfate, sodium bisulfate, or ammonium sulfate. You name any of these, they belong to a family called sulfate family. Just like you have a family of a particular clan, you have a number of families of salts that are available to us. Now, we know that the salts are produced by reactions of acids and bases, between acids and bases. And we have also mentioned, I've also mentioned to you some time back, that the acids, strong acids, when they react with strong bases, they produce salts that are neutral. For example, I said hydrochloric acid and sodium hydroxide giving sodium chloride. The solution of sodium chloride is neutral. It has a pH of 7. But you can have a salt coming from a strong acid and a weak base. A strong acid like hydrochloric acid, a weak base like ammonium hydroxide. So when you have a salt of these two, you get a compound called ammonium chloride. Ammonium chloride, most of you have seen this compound. If you have not seen it, you can always see it. It is present in the dry cell that you have, a battery cell, a dry cell. If you have seen a dry cell, just try to open it. As children, we learned, this is how I learned my chemistry, opening up things and finding out what are present inside. In the dry cell, the exterior part of it is zinc. And if you open it inside, you will find that there's a white paste. That paste is ammonium chloride. This ammonium chloride is got by the reaction of hydrochloric acid and ammonium hydroxide. I mentioned to you some time back that hydrochloric acid is a strong acid, ammonium hydroxide is a weak base. Therefore, the salt of these two, that is ammonium chloride, will have more H plus ions, less OH minus ions. Therefore, it is having a pH less than 7. Please remember, ammonium chloride is a salt got by the reaction between strong acid, hydrochloric acid, weak base, ammonium hydroxide. In solution, it produces both ammonium hydroxide and hydrochloric acid. I'll write it out for you because normally whatever I say doesn't register. I write out a sequence of reactions that will definitely make you understand a little more. Okay. Now, HCl find that I have written whatever has to be spelled out. I have written in a whole sequence of equations. See what happens. Ammonium chloride solid when dissolved in water gave me ammonium hydroxide and hydrochloric acid. Hydrochloric acid undergoes complete ionization, giving rise to hydrogen ions and chloride ions. We know it is a strong acid. Now, ammonium hydroxide, I said, is a weak base, partially ionizes into ammonium ions and hydroxyl ions. Therefore, solution will have more H plus and less number of OH minus. Because the number of H pluses is more, the solution will have a pH of less than 7. So this is called an acidic salt because the resultant solution is an acid. Now, if I take if I take another compound, maybe sodium acetate. I dissolve it in water, I get acetic acid and sodium hydroxide. Now you find acetic acid gives me, whereas therefore now look what we have done. Dissolved sodium acetate solid in water, I got acetic acid and sodium hydroxide. Acetic acid being a weak acid gave rise to acetate ions and less number of hydrogen ions, whereas sodium hydroxide being a strong electrolyte, we call it as, it completely ionizes into Na plus and OH minuses, and we find that hydroxyl ion concentration is more than the concentration of hydrogen ions. Therefore, the solution will have a pH of greater than 7. Such salts are called basic salts. So we have neutral salts, we have acidic salts, we have basic salts. We'll keep it at that. We will not go further. Now, common salt, it's a very historical compound as far as our Bharat is concerned. As far as our Bharat, Hindustan is concerned, common salt is a very historical compound, because if you have definitely read about this, that there was this very famous Dandi March that Mahatma Gandhi started, and when the Britishers tried to levy some, tax on salt being, taken out from the sea, and that sort of created a huge revolution, and then finally, ultimately, India got our independence, right? So the so-called Dandi March, as it is called, Dandi March. Now, this common salt is a very common substance, as we know. It's really common, available everywhere. And okay, just before I go, forget, let me add one more point to you. See, when we were young, right? We were also young. Okay, that I should make a statement. We were also young, right? We used to have salt we used to go buy it from the shop and then use this same salt. My mom used to use the same salt for everything, like no question of powdered and crystalline, etc. And we never complained about any kinds of deficiencies. Then somewhere in the 80s, around 80s, a concept was introduced where they said there's what is called free flow salt. They said the salt is sticky, common salt is sticky because it has magnesium chloride in it. Seawater contains magnesium chloride. So when you crystallize the water, when the solution, you get common salt along with some magnesium salts and of course calcium salts. This magnesium calcium salts are hygroscopic, so the salt is sticky. So somebody introduced the concept where they said you remove these calcium magnesiums from the salt and it becomes free flow salt. I remember long back, there was this very famous advertisement called Captain Cook salt, if I remember. But then they started removing everything. And they found that people started to develop a certain deficiency of iodine. Iodine is present in the seawater in the form of potassium iodide, which they had already removed earlier on. So they said iodized salt was introduced. There is nothing like iodized salt. Common salt contains enough iodine for all of us. But it is a gimmick that people are trying to sell the concept to us. They say that if your salt doesn't contain enough iodine, you're going to end up with goiter, etc. Believe me, in our nation, we will have no such deficiencies. Definitely we will not, because the kind of food that we consume is definitely much more healthy and much more better cooked than anywhere else in the world. All right. So the common salt. Common salt is just not used only for preparing delicacies. It is also a very important raw material for a number of substances, commercially important substances we are going to see now. Now, I said common salt is present in seawater. There's some comparison I should give you here. Seawater contains about 72 elements in it. The human body also contains 72 elements in it. And you should know that your pulse rate is around 72. We have 72,000 arteries, veins, etc. passing through the body. So that this number 72, and Earth is approximately 72% of water. There's a lot of similarity between the human body and, of course, the Earth and water that we consume. Now, this seawater contains, as I said, a lot of common salt, and also in certain places this common salt is found in the form of rock salt, deposits of hardened sodium chloride rock. So the rock is drilled out and you see that the common salt is taken out. So the two important sources of common salt for us, most common is from the seawater, less common is from the rock salt, NaCl as you call it. Now, what do we use this for? Where do we use common salt? To manufacture what do we use common salt? If I list out, you'll be surprised. Common salt is used to make chlorine, sodium hydroxide, hydrogen, hydrochloric acid, and for, of course, fertilizers. It is somewhere at the end use, you will find that. It is used in making common salt is the starting material from which you can make ultimately PVC, polyvinyl chloride, and a lot of things. We will see how these are going to be used and how we are going to represent the use of common salt. So what we do is we start with brine, not I, in the industry. Brine is subjected to electrolysis. What is brine? Let us see. Please note the spelling. A saturated solution of sodium chloride in water is called brine. Please note it is not brain, it is brine. Brine is subjected to electrolysis using a cathode and an anode. We will be learning this whole process in higher classes. So for the moment, we are not going to go into the chloralkali process per se, how it is actually done. We are not going to go into the details of it. Let us see. When we pass electricity through sodium chloride solution, what happens? Let us see. 2 NaCl plus 2 H2O in the presence of electricity gives me 2 mole of NaOH plus 1 mole of hydrogen plus 1 mole of chlorine gas. This is aqueous liquid. Now, hydrogen is liberated at cathode. NaOH is formed near cathode. Chlorine is liberated at anode. This process is called chloralkali process, because you can see that chlorine, sodium hydroxide is an alkali. So both an alkali and chlorine are liberated. This process therefore is called chloralkali process, right? So my friends, at this juncture, I think it is about 2-3 minutes to go by my clock. Let me just check. Yeah, I have 3 more minutes. If you have any queries at this point, you can raise them. If you don't have, I'll get to hear from my friend here in the studio. If there is no more, then I think we can take a break at this juncture. Okay, I'll just brief you on this again. Chloralkali process. This is an important question for me. We have brine, that is saturated sodium chloride solution, is subjected to electrolysis. I think I have mentioned this to you. Electrolysis is breaking down a compound using electric current. This produces sodium hydroxide near the cathode, not at the cathode. There is a process that happens near the cathode, and hydrogen gas is liberated at the anode, at the cathode, and chlorine gas is liberated at the anode. So this hydrogen, where is it used? Hydrogen is used, of course, as a fuel. I think we've been hearing this. It is used as fuel. It is the next future fuel, they say. We are talking about hydrogen being used. It's already used in spaceships. Sorry. It is used in spaceships as a fuel. In motor vehicles, they're trying to bring up this hydrogen as a fuel, which is not very far-fetched. It will happen soon. Then it is used in hydrogenation of oils, that is preparing your dalda, margarine, etc. Then it is used in the manufacture of ammonia. Ammonia is used as a starting material for a number of fertilizers, like ammonium sulfate and then ammonium phosphate. Then chlorine. We know chlorine is used for treatment of water, drinking water. It is used in swimming pools. It is used to make PVC, polyvinyl chloride, a very important plastic for us. It is used for the process of disinfecting. Nowadays, this is a common thing that we come across, disinfecting, and it is used in making chlorofluorocarbons and so on and so forth. Together, hydrogen and chlorine give me hydrochloric acid. Hydrochloric acid is used for, of course, cleaning of metals. It's called acid pickling. It is used for making ammonium chloride, and it is used in a number of medicines. Yes, looking at this, you look at any tablet that you consume, invariably, if it is an antibiotic, for example, or it could be some other medicine that is prescribed by a doctor, look at the composition. Somewhere they would have mentioned HCl, hydrochloride, because hydrochlorides of these organic compounds are water soluble, therefore they can be absorbed by the body. So it is used in medicines, it is used in cosmetics, and so on and so forth. So at this juncture, we take a break. We shall be meeting each other on the following Friday, when again we will retrace what we have done here and then go forward. And I think that would be the culmination of the second chapter when we meet on the next Friday. Thank you very much. Hope we have had a nice time. God bless. Thank you.
Thank you so much, sir. It was such a wonderful session. Would like to inform you, sir, that we didn't receive any queries. Okay. It shows the session was crystal clear for our viewers also.
Thank you so much. Thank you very much, Maria. Thank you.
Thank you, sir. Thank you so much. Dear viewers, please stay connected for many more sessions. Share the links with your friends. Please like and subscribe our YouTube channel. Tomorrow will be the next class, afternoon 3 to 4 p.m. Thanks a lot. Thank you.